Started?
Started.
Okay. My question was how you take over your watch. Okay. So I started like as soon as I get a wake up call, I'll get ready, wear my boiler suit, and proceed to the crew changing. Crew, I'll proceed to the changing room, wear my PPE, and proceed to the control room. There I will inform the duty engineer that I am having my round and I will be back within 15 minutes. I will start my round from the funnel deck. I will see the smoke, the color of the smoke, it should be light grey. That time he asked me that, what about if it is a night time? I said, sir, night time I will be looking for the spark. If it is small amount of spark, then when I finish my round, I will inform the bridge and I will carry out soot blow. Why you will carry out soot blow? Because soots get accumulated at the tubes in economizer, so it's better to remove the soots. And I say, okay, yeah, fine. Then he said, you can say, he didn't ask me, but he can ask you daytime if black smoke, then what is the problem? Black smoke means sub combustion is not proper. Okay, like more fuel, less air. If it is a blue smoke, excessive lubrication. Okay, and if it is a steam coming, then
White.
tubes, economizer tubes, and maybe leak, so it is carried forward. And then I said that after that I will proceed to the emergency generator room. There I will see the selector switch is in auto position, synchroscope is in auto. I will check some level of the emergency generator, check the water level.
Emergency generator synchro.
Yeah, have a auto synchroscope. So I will check all this thing. I will check the diesel oil tank level and everything. I will satisfy myself. After that, that time he asked me, what is the purpose of emergency generator? That time I said that when the standby generator fails to start, the emergency generator will come up in load within 45 seconds. So he asked me only this much. And after that, so I will proceed to the reefer plant. Before that, I will see the relevant temperature of the room, and I will see the suction pressure, discharge pressure. I will see the abnormal noise, vibration, and I will see the condenser gauge class level. So that time he didn't ask me anything. He just said me, okay, can you draw the line diagram, basic diagram? He said. I said okay, but he can ask that if you see the suction side is icing, too much ice on the suction side, then you can say that it may be overcharged. Okay, normally it says it can be overcharged. So I will look at the condenser gauge class and see the liquid. If small amount of bubble is there, then what is the small amount of bubble is there? Then air in the condenser. If large amount of bubble is there, then it is undercharged. Large amount is undercharged, no? Large amount of bubble you can see in the gauge class in condenser, that means it is undercharged. There is no reefer leaking somewhere system. Okay, these are the few questions in this reefer. So basically in diagram he can ask you the solenoid valve, function of solenoid valve, and thermostatic expansion valve. So you say for solenoid valve has a sensing bulb in the evaporator coil. It senses the temperature. According to that it operates the valve. If suppose you are maintaining in minus 19 for meat room, and requires still more cooling, then it will open the wall and let the liquid flow till it will proceed, carry forward the liquid till thermostatic expansion valve. This is the function. And thermostatic expansion valve has a sensing bulb at the outlet of the evaporator. So it senses the temperature. According to that, it regulates the flow in the evaporator. And what is happening in the evaporator box? A latent heat is transferred. Okay. During this latent heat, again this liquid is converted into vapors. Okay, that time. And the basic function of the thermostatic is that it makes the reefer liquid from high pressure to low pressure. Okay, from high pressure to low pressure by passing through variable orifice. Have a variable orifice inside, so it make the high pressure to low pressure, and then it pass to the evaporator box. These are the basic things for reefer. Then I said that I will proceed to the air conditioning room. They also same, I will see the suction, discharge, condenser level, and very important, I will open this box, lower box, evaporator box, and in this box I will see the drain. The drain should be clear. That time he asked me, why you require a drain should be clear? Sir, if the water is getting accumulated, have a chances of Legionella bacteria which cause pneumonia, especially to the elderly person on board. So Legionella bacteria is generated. That's why the drain should be clear. He wants that word. I said that after that I will go to the economizer, and I will see the uh, manometer, back pressure manometer. So he didn't ask me any question regarding this. And then I said that I will proceed to the expansion tank. So he said me, what is the purpose of expansion tank? So it is for the expansion of water. He says, which water? I said, sir, jacket water, main engine generator both expansion. What else? I said, sir, it gives positive idea. Yeah, it gives positive definitely. What else? What more? And I said, sir, it removes the airlock. So he said, no, something very important. I said, yeah, sir. We monitor the level. So if the level is going down, we get to know that something is leaking system, water is leaking in the system. So it is for that we can make up the water level also, and it is also used for chemical dosing. That time he asked me, or he can ask you also, that why you require chemical dosing. So we say that, sir, to reduce corrosion and oxidation in this cylinder. So how it can be how it can be corrosion can take place, because we are burning sulfur is sulfur, and this if this scavenge air have a moisture, so moisture, sulfur, and this sulfuric acid and corrosion. So this is the thing. So after that I take him to the boiler. I will see the boiler gauge glass level. That time he said, can you draw me the basic diagram of the gauge glass and blow through the gauge glass? So I explained him that I will make you understand. And then after gauge glass blow through, I said that then I will proceed to the steering plate. I will see the abnormal noise, vibration. I will see the level of the tank level. Then I will see the free movement of the rudder. I will see the rudder carrier bearing, greasing point. Everything is fine. Then I will check the communication. Communication is okay. And then he said, what else you have in steering plate? I said, sir, we have a emergency generator room. Sorry, we have a emergency fire pump. So I will just have a look down that there is any leakage of something, and this suction discharge wall is open. And then he said, what else you have? I said, sir, we also keep all chemicals. So he said that, what you lash or something? He said, no, we have a locking system. And so which chemical? He said. Then I said, so many chemicals. I said, for this jacket water treatment, boiler water treatment, have cleaning chemicals in this. So he said, okay, fine. What else you have? I said that, sir, we have a safety data sheet for this chemical handling. He didn't ask so much. Then I said that, okay, sir, I will come. I am satisfied with the steering plate, and then I will proceed. We have a generator for the three generators. So I will proceed to the generator. So he said, okay, so what you will do? So I said that first I will see that all three, this standby generator, all lube oil priming pump is running. And then I will check all the sump level of all the generator. Then running generator, I will see the parameters of the exhaust temperature, any major deviation is there. I will check lube oil, jacket water, and all relevant temperature, pressure, jacket, scavenge temperature, pressure. I will see the pedestal bearing and everything. Then I will see that turbocharger filter is fine, governor oil level, and we have a flap on the top for the air. So I will see the flap is enough open. And then he said me, okay, Mr. Patel, this generator is running for 2 days. Better will change over the generator. I said, okay, sir, fine. Then if I want to change over, then first I will see that the standby generator, I will check the lube oils and everything. I will check the sump level, governor, and all this governor, this turbocharger oil level, everything is checked. Fuel line is set, it is normally set. Then I will drain this air starting line. I will drain the air starting line. I will open the indicator cock, and I will put the standby generator in manual. I will put the starting lever to 0, and then I will blow through the engine. I will see any liquid coming from the cylinder. Then that time he asked me which type of liquid and why this liquid can come. Then, sir, maybe some cylinder head or liner is cracked, so see for this. Okay, Mr. Patel, fine. Then what you will do? I said, sir, after that I will close the indicator cock, and then I will put I will close the indicator cock, and I will so after satisfy myself, I will close the indicator cock and put this generator in. I will start the generator and I will put the starting lever to full position and I will start the generator itself, and then I will see, I will satisfy myself, I will see all the temperature, again pressure, everything is fine, and then before proceeding to the control room, I will put the generator in auto and I will go to the control room. There I will see the incoming generator voltage should be the same with the bus bar. Okay. After that I will put the selector switch for the incoming generator and on the synchroscope switch. There when I on the synchroscope I will get to know the incoming generator voltage and bus bar voltage should be same. The incoming generator frequency and the bus bar frequency should be in phase. When it is in phase, the synchroscope needle will slowly rotate clockwise. At the 11 o'clock I will close the breaker and switch off the synchroscope, and I will make the generator parallel. I will share the load by increasing the governor control of the incoming generator and reducing the uh, running generator and make it parallel. So that time he asked me this, he can ask you that why you want to immediately switch off the synchroscope, because it is not a continuous rating, have a small winding wire and it can get burned. So we switch off the synchroscope. That time he asked, so Mr. Patel, what are the safeties on for this generator? So I said that sir, we have a overload trip, we have a reverse power trip, we have a under voltage trip. So that time he asked me, what do you mean by reverse power trip? So I said that's a reverse power trip is required when two generators are running parallel. So this device monitor the flow of current from the alternator to the bus bar. Okay, and if due to some reason the prime mover is fail and it stop, that time the alternator will cause a motoring effect. It will start drawing current from the running healthy generator. So that time this device monitor this, detect this fault and remove this faulty alternator from the bus bar. So it is for this purpose. And then he didn't ask me, but if he asks for this overload trip, so what is this overload trip? When we have a excessive power, more than the rated power on the bus bar, if the load get excessive, that time this function to trip, it has a 20-second time delay. Okay, so first 20 seconds it will get a non-essential preferential trip will activate. So in that first 5 seconds, the this galley first 5 seconds this reefer plant will air conditioning plant will trip. Okay, air conditioning plant and blower. Then still the load is not less. Then after 10 seconds, this reefer plant and galley side will get tripped. And third, still the load is more than the third one. After 15 seconds, this deck non-essential machinery on deck will get tripped. And if still the load is not overcome, then this will activate overload trip. It will trip this generator. So it is for the safety. And for the under voltage, actually it is like if the voltage drops more than 50% voltage drop, that time it come into action and trip this. And it also prevent that if we are paralleling the generator, and if by mistake instead of closing the incoming generator circuit breaker, if we try to close the dead generator which is not running at all, and by mistake if we close, it will not get closed. It protects this under voltage protection. Okay, this is the main. Then this safety is finished. Then I said that after sharing the load, I will again go to the generator platform, see all the relevant temperature and all these things, see the exhaust temperature, any deviation. So that time he said, if Patel, if one of the unit have a more exhaust temperature, what will be your action? What can be the reason? So I said that time, sir, I will open the fuel rack cover and see maybe the fuel rack is stuck. So we do normally lubricate the racks. And he said, no, if it is fine, then what else? I said, then a faulty injector can be. So he said, okay, yeah, fine. But what will be your action if you are seeing this? You have already taken on load, and if that unit is having more, then what will be your action? sir, immediately I will inform chief engineer. By the time chief engineer come, I will take the other generator, standby generator on load. So by the time chief engineer come, the other generator is taken on load, and then we can rectify this, because we are sailing. Maybe the ship is going to hit the rock. So I will do this. He was very happy. Like, he wants safety. He don't want that we are going to repair and something. Standby generator is started standby generator, and this faulty part we can rectify. So that time specially you have to inform bridge also that we have this one generator problem. So they can also get to know that okay, they are having now only two generator, one is faulty something. So that time we have to inform chief engineer, and then bridge also should be informed for this. Okay, then generator part is finished. After that, I said we have a freshwater generator over there. So what you check in freshwater generator? I said, sir, in freshwater generator we check the vacuum, we check the shell temperature, we check this condenser seawater inlet outlet temperature, we check the feed, how much feed is given. We can see from the gauge glass the flashing of this freshwater. So he's saying, so how this is heated? So I said, sir, we supply this jacket water for this heating. So he's saying, so what temperature it get flash? I said, 45 degrees enough actually. So he said, why it is like this? So I said, that, sir, if in atmospheric air, if you try to boil the water, we require 100 degrees Celsius. But the same thing if we do in vacuum condition, it will flash up in 45 degrees. So okay, yeah, vacuum. So how this vacuum is created? I said, sir, we have a eductor system. We have two eductor. One is air eductor and one is prime eductor. So air eductor continuously remove the air and keep the system in vacuum. So what else? So I said, sir, that we have, I will check the distillate pump, I will check the flow meter is running properly, I will check the chemical dosing, it is enough. Otherwise we don't see this all, it will take air, so it should be, level should be maintained. And he didn't ask why this chemical dosing always. If he asks, then also you say that for the scale, prevent scale formation in the heat exchanger like this. And you practice for this freshwater generator diagram also. Whichever you have a plate type or tubular, whatever it is, they can ask for this freshwater generator diagram. I said, then so after this I will see this, we have a circulating pump, booster pump, I will see this, everything is fine, normal. See the differential pressure, we have auto backflush filter, and this he didn't ask anything. Then I said, we have an air bottle we have. So I will drain the bottle, drain the water. So he said, when you drain, what is that? I said, oil and water mix, it removes a white color. He said, why this water is coming in air bottle? I said, sir, in atmosphere, this air we are taking atmospheric air, okay? So it has a humid. So if we compress this in compressor, then this moisture is there, it will get collected, so it should be drained. So for that we have an unloader. So he say, what is unloader? I said, the unloader reduce the starting torque of the motor, and it also remove the accumulated moisture in the air cooler. Okay, so he said, okay, yeah, fine, good. So why this oil is not good for our system? So I said, sir, if this oil is carried forward in the air starting line, and if one of the air starting valve is faulty in the cylinder, one of the air starting valve is faulty, then we can have an explosion in air starting valve, because this valve is not functioning properly and it is remaining in open position. So all this combustion heat and spark and everything is coming in this line and can explode. So he's saying, what are the safety devices there? I said, so we have a flame trap in the line. Then on air starting valve we have a relief valve, we have bursting disc. And so he said that, what are the safeties on the air compressor? I said, sir, we have a relief valve on each stage, each discharge state. We have a unloader, we have a bursting disc, we have a last final line, we have a non-return valve. And he said, what are the safeties on the air bottle? We have, sir, we have a fusible plug and relief valve. He said, what is this fusible plug? I said, sir, when the temperature increases more than 120, so at 120 it will melt and relieve the pressure of the bottle. So, okay, yeah, fine. What else you will see? I said, sir, I will see the air filter is good. I will see the oil in the crankcase, and yeah, fine, okay, yeah, fine. Oh yeah, good. Then he said, okay, you proceed. Then I said, we have a hydrofoil tank. I will see the motor cut out, and during freshwater generator he asked me, okay, Mr. Patel, what this low temperature
એ આટલું જ કેમ મેમરી આટલી જ કેમ આવે મારી? 3 મિનિટ ને 42 સેકન્ડ ચાલુ છે.
Okay. So after air compressor,
એરલાઇન સેફ્ટી બોલતો.
okay. So this oil is undesirable because in this if this oil is carried forward in the air starting line, and if one of the air starting oil is faulty in the main engine, then it can get a explosion because this combustion atmosphere is coming in this airline, and it can explode. So we don't that's why we avoid this oil to be get carried forward, and we drain from the air bottle. uh, and we have a, so he asked me what are the safeties for this. So sir, we have a flame trap in air starting line, and we have a bursting disc, we have a release valve, we have a these are the things. And so he said okay, yeah, fine. And then after this I will come to the cylinder head platform. I will see all the exhaust temperature, and that time any major deviation in the exhaust temperature, I will check the all air starting line. It should not be very hot. We can make out from the color of the paint, peeling of paint. So if it is hot, that means we have to change this air starting oil. It is faulty. So these are the things I'm going to check. That time I will check the turbocharger oil level. I will come to the scavenge trunk. I will see the scavenge pressure, scavenge temperature locally, and then everything is fine. Then I will proceed to the camshaft platform. There I will see the lubricator functioning properly. We have a local parameters over there. For main engine we can see over there locally the lube oil pressure, sea water pressure, jacket water pressure, temperature. So I will see that. I will make sure the air cooler, sea water inlet, outlet, everything is fine. And then that time he asked me, okay, do you hear about the scavenge fire? I said, yeah sir. Can you explain me the scavenge fire, how it is? So I said, sir, due to the accumulation of unburned fuel in the cylinder space, and if there is excessive lubrication, and if this drain is also choked, then it get accumulated over there. And if the faulty rings, oil ring is there, piston ring, then if this blow past takes place, it can have the scavenge fire. So he said that what will be your action if you see this? What are the symptoms? I said, so the symptoms are the peeling of paint, local overheating is there, the exhaust temperature of the relevant unit rise, and scavenge temperature also rise. So that time I will verify and I will see. And immediately, what will be your action? I said, sir, immediately I will go to the control room, inform bridge, inform chief engineer, uh, slow down the engine, and then I will proceed to the cylinder platform. I will shut off the fuel line of that unit, and then on at the camshaft platform I will shut all the drains, scavenge drains. I will shut all the scavenge drains. If it is a small fire, it will subside after some time, but still the exhaust temperature is not getting down. Then sir, I have to again inform bridge and stop the engine, and prepare for the fixed firefighting of the unit. We have a steam for smoothing line. So after this steam smoothing and everything is done, I will engage the turning gear and turn the engine for 5-10 minutes ahead astern, and then after sufficiently cool, that time only I will open the scavenge. So scavenge fire, you got to know scavenge fire, okay. After sufficiently cool only, that time you will open the scavenge door, and then you will clean everything, and then verify all the problems. That time you will go and chief engine, second engineer will enter in the scavenge trunking, and there they will check with the piston ring and all everything. They will find out the fault, and after everything is clear, that after that only you start the engine. So scavenge fire is made. After that, I will he said okay, yeah, fine. Then sir, I will go to the bottom platform, and there first I will check the exist exist. There should not be any, the way should be clear. There should not be any obstruction. I will just open the door and see the light, enough illumination, lights are all okay. I will see the safety harness in place, and after satisfied myself, I will see the condition and state of readiness of portable fire extinguisher and EEBD. Okay, because we are in bottom setting, so it's very important. So he wants basically all safety, so he will say, with, after that also I will check the main engine seawater pressure and auxiliary seawater generator seawater pressure, because maybe the sea chest is getting choked, so sea chest filter, so that is the important thing. Then I will see all the pumps, any leakage, noise, vibration, everything is fine. Check various point at the bilges, any oil, water, see the bilge well, should be dry, and then I will feel the crankcase door, all the crankcase door, see the piston cooling outlet, flow, temperature. Then I will check this thrust bearing temperature. I will see the intermediate bearing oil flow. Then I will see the lip seal tank, have stern tube lip seal tank. I will check the level of this. After he said that you don't have oily water, so I said yes, sir, I am coming to that point. I said then we have a oily water separator. So that time he asked me, so what are the rules for the oily water separator? So you know the rules, how I will say. Okay, the rules are the the ship should have a certified oily water separator. Okay, it should have a 15 ppm oil monitoring control. 15 ppm oil monitoring control with an alarm. So when the alarm rise, with alarm and shut off of overboard valve. So three-way valve get activated, overboard valve is shut, and the oil, oil content water is goes to the bilge tank, bilge holding tank. So this is the thing. The ship should be en route. The oil should not be more than 15 ppm. Then the the bilge water generated, it should be from the machinery space and not from the pump room. Then the bilge water should not have cargo residue. Okay, these are the things. Then we have a oil record book. Oil record book should be maintained. And in this, you how you calculate this? So I said this before starting this oil water before
Better.
before starting this oily water separate, I will take sounding of the bilge tank and waste oil tank. Okay, and then I will inform bridge that I am starting the oily water separator. I'll see the location, start time, end time, and after finishing, again I will take the sounding of bilge holding tank and waste oil tank. So I will get to know how much water is being gone overboard and how much waste oil, how much oil has come to the waste oil tank. So like this I said, then he said, can you explain your bills, how your bill system is working? So I said that we have a primary, we were having this some different types. We are having a primary tank. So from bilge well the water goes to the primary tank, and from there only oil gets separated and water goes to the bilge tank. Like this. So yeah, okay, fine. So this was the thing for oil water separator. And then he said, okay, yeah, you are fine with the watch, so good, okay. Then last he took me to the deck stability. He asked me this, no, then he asked me this fixed firefighting, but he didn't ask me full. He said, what are the, what was having on the system? This I said, the CO2 system. Oh yeah, okay, CO2. So what is the procedure? So I said, sir, if we have to do this, then first we'll take a head count, and after that isolation of engine room. Carry out isolation. So that time we'll all sort of keep closing all ventilation, fans, blower, everything of funnel flap should be shut, and skylight and every engine room should be sealed, and make sure everybody is present. And that time chief engineer will talk to the master, and then he will release the CO2 system in engine room. So 85% of CO2 should be released within 2 minutes. So he said, after the CO2 release, what you will do? Just stand? I said, no sir, boundary cooling is going on, so we'll carry out with boundary cooling. So he said, yeah, okay. So after that he said, yeah, okay, fine. Then if the chief officer is not maintaining the loading plan, and if your what will happen in the rough weather? So I didn't know. So I said, sir, the stability problem. Yeah, okay, stability. I said, sir, the center of gravity will move to where the load is added, and this. Yeah, that's okay, but what? So I didn't got only this. Then he only gave me hint that have you heard about shagging and hogging? So I said, yeah, so understood now. So I make one wave like this big, and one point and one point after, so from this middle we have a bending moment if cargo is like that. So okay, fine. He passed me that way. oil mist detector diagram. And what it does, the have a pan, it takes continuous sample from each crankcase, and this oil mist detector have a measuring tube and reference tube. The sample is drawn and flows to the measuring tube and goes out. So during this time, if the mist formation is there, mist concentration is there, then the electrical will get imbalanced because they have a photoelectric cells and lens and light and mirror. So it is fully balanced, and if this mist concentrate, mist formation is there, concentration is high, then it will imbalance the system, and it will get compared in the comparator, and alarm will raise and slow down the engine. Right. So this is the oil mist detector. And
એટલે બે ટ્યુબ એક જગ્યાએ કરવું બરાબર ને?
yeah, one reference you have a fixed air inside, and this measuring tube have present, they have a fixed value. So if this value is exceed, like mist concentration is more, so that time get imbalance and activate alarm and slow down the engine. Okay. And diagram you have to practice. I will show you the diagram. You can click. Okay. So oil mist detector, and then you can ask you regarding economizer fire. So what is economizer fire and how you will get to know? If it is small fire, we will carry out full flow point. And what are the, if it is a economizer fire, what are the symptoms? If it is a economizer fire, that means tube is burst inside. Okay, tube is burst and metal fire has taken place inside. Metal is firing. So that time high steam generation rate will be very high. Gauge plus water level coming down. Heat pump continuously running, gauge plus coming down. So that time you will get to know this. And what are your action? Your action will be first inform bridge, inform chief engineer, then slow down engine, stop the engine. After stopping the engine, then you have to stop if the condition is worse. Okay, if the condition was the tube is broken and water is too much steam and fire, then that time you have to stop the speed water pump. Okay, because you are giving more water and more hydrogen fire is taking place. So that time you will stop this circulating pump and drain the water also from this. And if you have a washing system line, then open this and put in the heart of fire, carry out boundary cooling. These are the only procedure. But if the tube are not bursted and everything, and only still fire is taken, that time you will increase the circulation. If tube is not bursted, you will start other standby pump also, so that the cooling
Tube cooling.
yeah, tube cooling is heat transfer increase, rate of heat transfer is increased. But if the tube is burst, that time you have to stop this pump. And as I said, boundary cooling, and this washing system has to open this, and these are the only for the economizer fire. Then sewage plant, they will ask sewage plant. During my watch, I take tell in the sewage plant and all. So sewage plant, what are your checks? So if during your round sewage plant is coming, you just check the air supply. Should have continuous air supply, and the chlorine tablet should be there. These two things we have to check in sewage. So if what if the oxygen is stopped? If the fan have problem, it gets stopped, then because we are generating aerobic bacteria. Okay. So if the oxygen is stopped, this aerobic bacteria will die. And what will happen? If this aerobic bacteria dies, anaerobic anaerobic bacteria generate family. They are also equally efficient, same like aerobic bacteria. But these are dangerous for ship because after digesting this human waste, it releases methane and H2S gas, which is highly toxic and flammable. So on board we use only aerobic bacteria, but on the land we use an anaerobic bacteria because we are using this cooking gas. That is anaerobic. They don't require oxygen fulfill, but the aerobic bacteria require oxygen. So what this if we ask regarding sewage plant, if we ask, then we say that according to the Annex 4 regulation, the human waste should be sterilized before disposing to the sea. And this sterilizing process consists of biochemical oxidation. Okay. So this biological sewage treatment plant utilize aerobic bacteria. What it does, it digests the human waste and break down into CO2, water, and inorganic matter. Okay. So these aerobic bacteria require oxygen, so we continue give the oxygen supply when this in the aeration tank. The sewage enters soil inlet. What we are doing is it all enters in the aeration tank, and there's this aerobic bacteria. We are keeping them alive. It multiplies. It is digesting the human waste, and this activated sludge get transferred to the settling tank. By the further more incoming waste is coming, so it goes to the settling tank. In the settling tank, it gets settled. Okay, this activated sludge gets settled, and we have a air distributor. So we get that settled activated sludge again get airlift and again go in recirculation to the aeration tank, and this way it continues like this. So this oxidized, uh, this activated sludge gets more fast oxidized, and after that, in that we have a surface skimmer which the floating debris they filter it like this, and then after this, after the treated water is then finally passed to the chlorination chamber. So there in chlorination chamber we make sure that all the bacteria dies before going to dispose to the sea. So the when it goes to the chlorination tank, that time you have to say effluent. It becomes you have to say effluent, treated one. The effluent, we have to treat this effluent, and in chlorination chamber it gets killed, and then it goes to the sea. And rules and regulation. Treated one, the treated one should not be more. It should be more than 4 nautical miles, and the untreated one 12 nautical miles. But you better don't say untreated one. Say treated one 4 nautical miles. And why it is not recommended, because this, if you directly untreated, if you discharge it, then this floating shit, it requires too much of oxygen to break down. Okay, so it utilizes the oxygen in the water, so it oxygen deficiency can take this, which is required for the fish and plants. So because of this, rules has come, that is called bio-oxygen demand, BOD, bio-oxygen demand. And one more thing is the E. coli. The bacteria is called E. coli, E. coli bacteria, E. coliform bacteria. So we also measure the count. The E. coli bacteria count should not be increased more when it is discharged. It is something in 250 ml. It should not in 250 count into 100 ml. So this is the sewage rules and regulations. Then sewage is finished. After this,
Purifier.
purifier I didn't take him to purifier. I know everything, but purifier is very complicated. He can, if he wants, he can rap you. I didn't take him, and he also didn't rap you. But if he asks, then you learn this gravity disk. He will ask selection of gravity disk. So how you will select the gravity disk? So you say the selection of gravity disk depends on the three main: viscosity, density, and temperature. If we know these three things from the nomogram chart, we can get the correct size of, in this nomogram chart you can get the correct size of gravity disk. And the basic thumb rule for the selection of gravity is that the largest diameter gravity disk should be used, which does not break the seal. Okay, this is the gravity. And what is interface, we can ask. So interface is a boundary line made between the two liquids to separate, because we have oil and water. So we have to maintain that interface. It should not be too large. If it is too large, then oil will escape with water. If it is too small, then water will come with oil. So we have to maintain this interface, and this interface will be maintained between the top disk, top disk, top, top disk edge, and the stock edge. We have like this much interface. So you have to maintain in between this. If it is too large, the oil will go. Okay. So you just remember, too large, bade bill wala. Too large, oil is going. Oil is costly also, and too small, water is going. छोटा दिल है, खाली पानी देगा, oil देगा. This is the thing. So he will ask this. Then he will ask how many operating water is there. Then you say that sealing water is there. we have a operating water, we have a sludging water, three main things. Then he can ask you desludge of purifier. So how you will desludge the purifier? First we will stop the feed, put in recirculator. Okay. After stopping this, open the sealing water. Open the sealing water, you will see the water coming out from the side glass. You can see the once the water is coming out, you stop this sealing water. After sealing water is stopped, then you close this operating water. Okay, close the operating water, open the sludging water. A characteristic sound you can hear. Okay, for 2-3 seconds characteristic sound. Immediately stop desludge, open operating water, close the desludge, and then wait for the RPM to come. You can see the amp. When you desludge, it will go high, very high it will go. So let it come to the normal. Once the RPM attend, and then you open this operating water. Again carry out once again, open sealing water, let the oil flow. You can see in the side glass. Then stop this and open slowly open the feed and resume this, and then maintain the back pressure. So why you maintain the back pressure? So we maintain the back pressure for this interface. Okay. Also back pressure is maintained for this. We have a centripetal pump on the outside. So centripetal pump should be always immersed in oil. Okay. So this centripetal pump is always stationary. This pump is stationary. Only the liquid is rotating inside. So it should be little bit immersed. So according to that we keep this back pressure. These are the things in purifier. Then what are the checks in purifier? As soon as you enter the purifier room, first you will check that the exhaust fan is running. The exhaust fan, if exhaust fan if it stop, what will happen? Sir, the fuel will contaminate the engine room. Fumes are coming, fumes that can contaminate the engine room. That's why exhaust fan should always be running. First thing is like this. Then you check the gear oil level. Okay. Check the motor amp. Should be normal, like in our simple 15 amps. So check the amps of the purifier. See this back pressure, oil. Open this sludge port and see oil, water, and things coming. These are the things in purifier. Then in purifier room you have settling time, service time, filtering the water, and what are the operating procedures you can ask. I said you about the sealing. Why sealing water is required? Sealing water is required. We fill the bowl with water. Okay. So we require some interface. Okay. With liquid and fuel oil between two liquids. We require this interface. So we open the sealing water and keep the bowl full of water. When it is running in centrifugal force, that time it maintains the seal, and to maintain the seal for the separation, for the effective separation. So that for that purpose sealing water is required. And why operating water is required? The operating water is required. The operating water, oh, we have a sliding bowl. So this operating water goes below the sliding bowl and keeps the bowl in up position, closed position. Okay, it always lifts and keep in closed position and going on. Okay, everything purify process going on. After that, after 10-15 minutes, sludge is accumulated on the periphery of the bowl. Okay, so we require to remove this sludge. So that time, when we open this sludge water, it drains this operating water from down. So this bowl comes down. When this comes down, this sludge also break up. When it comes down, sludge break up and the hole is matched. The bowl hole and when it slide down, it have a hole. It matches, and due to centrifugal force, this sludge is thrown out. And then after this, again we operating water again lift open and lift the bowl. So these are the things. These are the things for the purifier. I had sufficient knowledge, but I thought better if he asked, then only I will take him. I didn't take him to purifier. Then what else you can ask regarding? You can ask main circuit.
Heat exchanger.
Heat exchanger, you have plate type cooler and this tube type cooler. So what are the difference?
What you check in that?
You check the seal. If it is plate type, you check the any leakage from between the plates. That you have to check.
So your temperature deviation.
Temperature deviation you have to check in both the coolers. But he can ask. He will not ask like he will say what are the difference, advantage, disadvantage. What are the advantage? Main advantage you say. I will give you cheap Indian answer. Main advantage. Main advantage of plate type cooler. You can increase its efficiency more. Okay, because in plate type cooler we have small. But if the if we increase, suppose for example, if we increase the engine power, we are putting more big cylinder liner and all, we are increasing the power. More power, more heat generation. So that time if we have a tube type cooler, we have to remove it and throw, and we have to install a big tube type. But in plate type, we have small. You just open, add 15, 20 plates more. No need till there. So this is the main difference. You understand? With heat transfer, you can add more. You can add more plates. Still, you don't require to throw all this thing. This is the main difference. So other difference, it increase the surface area. Cooling surface area is increased. Like say in air cooled pipe, we have a pinch. Why we have pinch? Because on cylinder liner we have pinch. It increases the surface area. Only we don't have pinch, then only we have this only. But we are increasing the surface, cooling surface area. So in plate type we have so much. Have a what we call just now I don't remember this.
Boiler safeties.
Boiler safeties, boiler safeties are there. We have a high level alarm, low level alarm. Then we have a flame failure trip. Then we have a fuel oil temperature, low temperature, fuel oil pressure, low pressure. These are the alarms and safeties. We have a safety valves and all this thing, vent valve. These are the safety blow down, come down. All boiler mountings they are mounting. In this mounting, whatever is there in boiler, like we have main feed valve, auxiliary feed valve, we have main steam stop valve, we have vent valve, we have safety valve, we have all FD fan, full FD fan, everything is in mounting, gauge class, pressure gauge, seismometer, everything is in mounting boiler. And flash up the boiler from cold condition. You have to flash up the boiler from cold condition. Like if your ship is in dry dock, maybe in Sweden, ice is falling. The same question in my college, the sir asked me, Polish. He asked me, okay, we are in Sweden, ice is falling, 2 months, this boiler stop. Okay, now we flash up the boiler, how we will do it? We have only shore supply. So that time you will say, first I will press up the compressor, I will start the compressor, press up the air bottle. Okay, because for automation we require this air. Now fuel line and everything is cold, so we don't have steam to heat. So first we'll start air compressor, press the bottle full, then set the uh, diesel oil line and automation air line for the main and pilot burner. Okay, main burner, pilot burner, set up the diesel oil line and air line. Then boiler is cold and major work has been done inside. So first I will check steam side, water side, furnace side, everything is clear, not unwanted material is there. After everything is fine, then I will, before starting, first I will make sure that feed valve, vent valve, this main two valve are open. Scum blow down, bottom blow down, main steam stop valve, it should be in shut position. Okay, still running also. So still running.
Mm.
So this should be in shut position. Okay. So first thing I will do, I will start the feed pump manually, and I will just fill the water till the low level alarm goes. When this low level alarm goes, I will stop feed pump. Okay. Why I will not take full water? How much we are taking? Only low level. Why? Because the water is cold, requires some space for expansion. So that only till the level goes up, I will fill the water. As soon as the low level alarm goes, I will stop feed pump. Then I will purge the boiler for 4 minutes. Purging. Why purging is required? Because maybe there is an explosive mixture, this fuel nozzle is leaking and have explosive mixture inside, can have explosion. So purging means we are removing this explosive mixture and charging with fresh air inside the furnace. Everything is removed and we charge this furnace fresh air. That's why we purge it. We purge it with a full flap. Every fan flap is full open when purging. After purging, the flap comes to the 10%, small, little air, not full. And then igniter pilot burner. Pilot burner will burn, and then we on the main burner. When the flame when the main burner take over the flame, we switch off the pilot burner. Then we have to slowly increase the steam, slowly. Like 2 minutes start, 15 minutes stop. 3, 5 minutes start, half an hour stop. So 6 to 8 hours we have to wait. Why it is for even thermal. Otherwise, on all of a sudden, if you give thermal load, it will get fracture. So for even transfer of heat, okay, we slowly do like this. And when the steam start oozing out from the vent valve, that time we close this vent valve, okay. After closing this vent valve, then you sufficiently raise the steam pressure and your boiler is ready. This is the boiler starting from cold, cold condition. After this, what else we have done? Boiler steering a rules regulation you have to know. What are the rules regulation? I didn't tell the rules regulation. So steering a rules regulation, first the steering gear motor should have a two wide separate connection, one from the main switchboard, the other should be from the emergency switchboard. Then second point, the motor for the steering gear have a 100% overload capacity, only giving short circuit protection. Second point is this. Third point, should have a direct communication facility from steering gear to bridge. Telecommunication bridge. Fourth point, should have a rudder angle indicator, one in steering gear, the other on bridge. 4.3. Fifth point, should have a single failure criteria. Single failure criteria means if due to some reason one motor stops, the other motor should start within 45 seconds. After that, should have a low level alarm on tank. Low level alarm. These are the rules. And and the other thing is that in the rudder movement should be able to move from hard port to hard starboard. You say from 35 degree to 30 degree within 28 seconds. In full loaded condition and in
Ballast
full
condition.
in full load in full loaded condition
And ballast.
and full loaded means maximum. In full loaded condition, it should be able to move from hard port to hard stop from 35 to 30 degree within 28 seconds. Okay. And the single failure criteria have two things. One is if motor have problem, it will start. Other thing, if the hydraulic line of one cylinder is leaking, then the low level alarm activate and other should, so it should effectively function. It should have, the design should be such a type that it should be able to steer. If the hydraulic line is also faulty, it should steer the ship like this, single failure current. So these are the rules and regulations for steering wheel.
Incinerator.
Incinerator, you don't ask anything, but incinerator, what we say, we have a flame failure alarm, we maintain 500 degrees temperature, it cut off, and we burn this rag, is used for burning this waste oil. And when we are burning this waste oil, we are recording this oil record book. So it is only for the incineration. Okay. Then you study regarding this garbage plan and everything. Then over here they don't ask this anything. Up till now I don't hear that MSN, IMO, ISN, but it is important. You better prefer to go to ISN because I got this other survey something different. So he asked me regarding some different questions like something like he can ask anything. So you better prefer for this. What else is left? Types of pump. Types of pump in engine room. We have a dynamic pump and positive displacement. We have two branches. One is like two branch, boy and girl like this. So we have dynamic and we have positive displacement. In dynamic we have centrifugal, inductor like this. And in positive displacement we have a reciprocating pump, we have a gear pump, we have a screw pump, we have variable stroke pump like this. These are all positive displacement. Positive displacement pump are self-priming, not required priming. It have a relief valve on discharge side. And centrifugal pump, they don't have a relief valve. Okay. Then centrifugal pump are not self-priming. It requires require some things for time. Then
In lubricator, what you check? In lubricator, main engine lubricator.
main engine lubricator, you see the ball is pumping. Tup, tup, tup,
But
tup.
if it is not ball like alpha lubricator,
Alpha
there's a
lubricator,
blinker.
then blinking
Mm.
is there. So I didn't sell like this. I got every time fault. So
I sell the new ships. That's why like it.
so this is the thing. Still the air conditioning we
And
require.
then that funnel flaps.
Funnel flap we have is from the uh, control station, fire control station. We have this pneumatic control.
No, it is monthly try out.
Every Saturday routine. It says it's every Saturday routine. Okay. Lifeboat launching
Lowering.
and recovery. Okay. So head count is taken. After head count taken, sufficient warm clothes, sufficient ration, food, EPUB, SART, everything is taken. Then first thing I will do is remove the battery charger line, put the drain plug, see the drain plug is in proper place. Then make fast painter to the strong point, remove forward guide, aft guide, remove the safety harbor thing, and remove the cradle stopper. हेलो अरे ठाकुर आ गया कल
Stunt.
No, for we didn't finish what you were saying. Launching and recovery.
Mm.
So, yeah, what I said, I was make fast painter the strong point, remove forward drive, aft drive, then remove this harbor safety pin, remove this cradle stopper, and then everybody board on ship on this lifeboat, make belt and strap, everything, head count taken before closing the door, make sure everything is clear down. Okay, and then we have one thing I missed when arranging. First we have to remove this brake winch lock pin.
Mm.
Okay, there is a lock pin. So starting only you have to remove this lock pin, and then uh, after head count everything is taken, everything clear, then you gradually release we have a release mechanism, so gradually release it slowly the boat comes down. That time you start the lifeboat engine. Okay, once the boat is waterborne, we have a hydrostatic release unit safety system which unlock which is a safety feature after the boat is waterborne. The water pressure act on diaphragm and unlock this lever, and so after that you can release this by removing the T-type locking pin and press the bar, this T handle against the spring, and the boat will release. And after releasing, immediately steer away from the ship. And again recovery, he will ask, and you say that also bring back ship to the align to the boat falls. And so okay, that time you have to remove the painter also. We have a toggle. You have to toggle. You just remove the toggle pin, and painter is also
Let the panther go out.
painter go out. So after when we are recovering again, you connect this boat hook, arrange, and then slowly heave up. So that time we want to use this limit switch. So you say slowly. I will heave up at one moment, at one position. The limit switch will stop this motor. Limit switch will stop this motor, and then with manual handle you can again lock. And in CO2 system, ships by what you are having?
Life raft.
Hmm?
Foam.
Foam type. Foam type. I don't
તમારું
know.
વાંચ્યું foam.
Foam.
But it's foam type.
You write on this portfolio.
We don't write portfolio.
Then
We
you say
just sign
CO2.
like this, but we write some task, no?
Hmm.
So I don't put, I remove so many things now.
So CO2, you say CO2 then. CO2, we have diagram also, and all, not complicated. So CO2, he asked me, I said only CO2, but he wanted the isolation process. So for that, I already said or not? I already said.
Already said.
Huh?
Life raft.
Life raft, I don't know, but it is very easy. You remove this locking pin and make sure everything is clear. Remove sufficiently. Open the painter. Okay, sufficiently remove this painter. Make sure everything is clear, and then throw it overboard. And after throw, give a jerk. The CO2. Nobody asked, but just say just remove this hook and
Class of fires.
latching. Class of fire we have A, B, C, D. So A, don't say E because in my book I don't see E. Only usually A, B, C, D. If he asks then only. So we have class A is solid, class B is liquid, class C is gas, and class D is metal. Okay. Then he says more than the class E electrical. So what is the difference between CO2 and how you can make out the difference between CO2 and foam? So color coding is there. Color coding. In color coding, CO2 is full black color. Foam has a cream color foam. Then dry powder has blue color, and water type has full red color. These are the color coding. So from color coding you can make out. Now nothing is there.
पटी बैटरी पटी
Huh?
बैटरी पटी